Hey guys, welcome to our Twitch stream on Robocar Rally. We have Justin here. I'm Sunil. Hopefully, you're joining and you've tuned in for the first episode. And if not, no worries. We will actually do a quick recap of the episode one. So folks who don't know, we're actually going to have an autonomous driving hackathon, which we've named Robocar Rally at reInvent, November 26th and 7th in Las Vegas. So in preparation, what we want to do is help you guys, build a car that you can bring to the hackathon. Kind of showcase the whole setup. Also, what we want to show is how easy it was to build something as fun as your own car that can drive itself. And Justin, you want to talk about your experience building the car?
Sure. So as we covered in the first episode, we built the car using open source project, using a remote control car, a Raspberry Pi, and a few other parts. And when you assemble it, you end up with an autonomous car that's capable of learning how to drive. And that's what we're demonstrating today, is learning how to drive your autonomous car.
Yep. Perfect. So in episode one, we actually had a couple more people, Will and Adam, who are part of the Donkey Car community. So the entire project and hackathon is based on a project that was created by them, and so we have adopted that as a platform which integrates with AWS to build the car. So we want to make it as easy as possible for developers participating, not just at the hackathon, but if you want to have this in your backyard, being able to do this. The first episode, we actually showed you how to set up your car, get the hardware, what was required, integrate that, build your car. And so once you've done that, you should have something like this ready. So I'm just curious, how many people who tuned in have gone ahead and built a car, or at least made some purchase? Yeah, let us know. So I'm watching the chat.
And for those of you that maybe haven't yet and you're looking for the opportunity to do so, this really only takes about 2 hours to build. So from unboxing it, getting it to your house, unboxing it to the point where we are today, it's just under 2 hours worth of work. So a pretty small time investment for a really cool bit of technology.
Awesome. Yeah, so we've got Babu Srinivasan says, completed my car yesterday.
All right.
Awesome.
Good job, Babu.
Good job, Babu. And then, Smith Woodward says he was watching. Great session. Thanks, Smith. Thanks for the compliments. Also, just curious in general, how many of you or what are the kind of languages you like to code in, or how many of you have deep learning expertise? Let us know. Yeah, we intend to have support for other deep learning frameworks. So right now, this is based out of Keras. So we'll add MXNet integration, even Gluon, which is the imperative interface for MXNet, which was officially released yesterday. It's a joint project between AWS and Microsoft. And then we will have TensorFlow and maybe even PyTorch as parts, so that customers have freedom to choose the deep learning framework that they want.
Yeah, it's all about having the flexibility to develop the way you want. It's a very open format. Again, it runs on Raspberry Pi. You've got a lot of choices on how you want, what deep learning frameworks you want to use, what programming languages, and also what sensors you want to add in as well.
Yeah, I think we'll cover that in subsequent episodes on other sensors that you may add. Because right now we just have a camera that we use on the car. Although Justin does have some wheel sensors.
It'll be ready to go for the next episode. We'll be demonstrating collecting telemetry from different sensors.
Awesome, I'm excited. Yeah, Babu just says Python and TensorFlow are his favorite.
Cool.
Very cool. So most of the car is actually
You'll be able
built.
to dive right in then, right?
Yeah, I mean he's already built the car.
Oh,
so,
good.
In Python's, has become the de facto language, I would say, for the data science community and people who are hacking or building deep learning models. Cool. So I guess what are we going to do today, Justin?
Yeah, so I think we're going to start off by showing how this autonomous car is going to drive this very simple track on the table.
Yeah.
And then we'll go through how the exercise of training it, driving it, getting to the point where you can have a self-driving car of your own.
That sounds exciting, man. Nothing like to see a live demo.
Yeah.
So fingers crossed. Let's actually try and get the car.
Ready to give it a shot?
Yeah. Let's give it a shot.
Can you just plug in the power for the battery?
There you go. So this is actually a dangerous course for the car, as you can see.
We went right for a high-risk course with
there's a potential for the car to fall down, but we drove the car for about 5 to 8 minutes.
Yes.
So it's adequate
It's
training
very
data.
basic because we have a very short course.
Yeah.
So we collected about 5,000 training images for that.
Okay. Awesome.
And what the community is recommending is somewhere between 10 and 50,000.
Right.
So obviously,
Right.
the more complex it is, the more
Right.
curves,
Yeah.
you want to collect more.
Correct. So just a little bit on the track layout. We just have kind of a line following, track setup. But typically, you might want to have 2 lines and actual track. But again, given the amount of space constraint or the space we have here, we just went with a single track, just to kind of demonstrate to you guys how easy it is to get started.
Right.
So maybe we'll give it a shot.
All right. So you can recreate this on your own at home.
Yeah.
Essentially, I'm tethering the donkey car and my tablet to my phone, along with my laptop. This way, we're able to have full control over it, very low latency, so it's able to obey the commands and not have any risk there. So
yeah, we have Mossman says floors are not bad choice for driving. Yes, of course. I do highly recommend using floors.
You want to start in a safe
area.
And I'm sure the roll cage is strong, but we don't really want to test it out too much.
Correct. All right. So Justin,
I'm going to take control.
I'm gonna make sure and look and save the car if something happens.
So before I get started, I want to talk about a few quick tips and tricks for driving. So on my screen here, you can see we've got a number of options for controlling it. And especially on a course like this, we want to set the max throttle to a small number. This way, when we're driving it, it doesn't go really fast because this car is capable of going very fast.
Right.
So we want to put it on a speed that's manageable for this course. So we're going to set our max throttle to 30%.
And then Babu Srinivasan says, hey, are you running the code on the Pi or AWS? So in this case,
is completely on the Pi right now.
Yeah, so it's local. So what we've done is we've trained the model on AWS because it takes a painfully long time training
on the
even
Pi.
5,000 images on the Pi. But on EC2, I think we were able to train in less than 30 seconds.
Yeah, it makes quick work out of it. So,
Yes.
And also you don't
Especially with
burn down the battery on the car. It's a much more effective way to do it.
So, and then the trained model we actually copied onto the Pi. And we'll simplify this integration. Like we're gonna be working on this, simplifying that flow. But for now, we had to copy it over.
Yeah. So we're setting the max throttle. The other thing that we're going to do is we're setting it to local angle. And by setting it to local angle, we're now giving the steering control to the car. So I'm going to drive with my tablet because I'll have better control to control the throttle by moving it up and down like this. So I will start vehicle, and here we go.
So this is this driving by itself now, or?
I'm controlling the throttle.
Okay.
And he's controlling the
Okay,
steering.
all right, so it's self-driving, but with a fixed throttle.
Yeah, here we
All
go.
right. All right. Still almost on the line.
Nope. Not a success the first time.
We'll give it a little help. We'll give it a little help. I think we need more throttle as it's stuck.
We're stuck.
I'll help it a little.
Okay, you followed that curve. Let's try it again. I trained it in both directions, so we can actually drive back and forth. But
We'll just give it this another shot.
give it a shot.
Yeah.
No, it doesn't like that.
All right.
Try to start it at the other end. Let's see if it can come back. Let's
All
try
right.
that.
All right.
Here we go. Watch it. Going off.
Yeah. All right. Justin, you might want to move a little bit. We can.
This model is. Oh, I have the wrong pilot. Let's try it again. Set it again. My mistake.
All right, guys. This is what happens, right? Like we might not.
Trial and error with this.
Yeah.
A lot of
So
human.
make sure so you can have multiple models ready. So we want to make sure you label them. Some of the basics, as I say, like in computer science, two of the hardest problems. One is actually caching. The second one is naming.
Yeah, naming.
So we've all been there. We've all been there.
Let's try this again.
Okay. Reset. Throttle.
I've lost control of it. Or I have.
You want to stop the
Can you
vehicle?
unplug the battery and plug
Okay.
it in again to the. Yeah.
There we go. The
Yeah, let's try
classic,
that again.
the classic IT move.
Yeah. Reboot it.
There you go.
We're not rebooting the Raspberry Pi. We're just unplugging the power to it.
Okay.
No, I still don't have anything. Let's try this.
Oh, there you
Here
go.
we go.
Oh, that was scary, but it recovered. That's awesome. And
There we go. Let's try it one more time. Turn it around. Let's see if we can send it back.
okay. All right. So who programmed this thing? It programmed itself, guys. Oh, look at that.
All right. A little bit more success that time.
Yeah, it's a tight curve there. It's quite impressive for what it did with 5,000 images.
Only 5,000 images?
Only 5,000 images.
Yeah.
That's pretty cool. Yeah, I mean, we'll talk about some of the other techniques that you can have so that you can augment the data. Will come when we do the training part. Let me quickly look at the comments that we have. Like, yeah, we have folks rooting for us, so thank you.
All right.
Obstacles on the road, World Zender. We'll do that. Maybe in a bit. Let's actually go through how we got here. And let's kick it up a notch. So yeah, stay tuned. Maybe in 20 minutes, we'll add some fun obstacles and see what happens. Berserk says, it sounds super loud. I'm sorry about that. Yeah, effects of live presentation. Yeah, Twitch EML says, the model is identifying the white line. Adjust the wheel. Okay. So here's the thing. So the process what we're going through is called behavioral cloning. So essentially, the model that you learn, or we're trying to learn, is how you trained it. So it's basically taken Justin's driving skills and trying to replicate that. So. Yeah, I think
And we'll see that unfold. It's not as easy as you think to drive this.
Yes. So essentially, what it learns is, given a particular image, it's trying to say, hey, what's the angle that I need to take at a certain point? And that's the prediction that's happening at every point. So we sample, I think the sampling now is every 200 milliseconds or 250.
30 frames a second or something?
No, the prediction part.
Oh, the prediction part.
The prediction part. So essentially what it does is we get that particular we get that particular angle at every point, and then it moves ahead. So having two lines kind of helps it learn and kind of have that more index and predict more things, because there are more things in the image.
Right. It's got more cues of what it needs to do.
Yeah. And so in this case, it's as I said, it's a very simplistic one. We worked with what we have to show that even something as simple will help you get to a point. We've got some people, Woots, and that's pretty cool. There's no problems. The student says, Snow Cave wants to ride it. Mark Richmond wants a cool Amazon AI hoodie. Let's see what we can do there. Smith Woodward talks about doing better than some other people driving in the physical world.
Yeah,
so.
it certainly can be an improvement for a lot of other drivers out there.
Mossman is emoji. I think I know who it is, but I don't want to mess this up. Yeah. Okay. Cool. Why don't we dive into what. How we got here.
Okay.
So let's actually walk through that process.
Perfect. So what we can start by doing is starting to drive on our own and then create our own model from that. So to do that, let me stop the current pilot.
Do you want me to unplug?
I think we're going to just drive it now and just try to
Wonderful.
try to learn. So let's get this started. We're going to cover this in a detailed blog post of using the run command to invoke commands directly on the donkey car. So we'll go into a little bit further detail of why I'm doing it this way. But essentially, from the AWS console, we are telling the car to start driving.
Yeah, that's a good point. So we do have blogs. So the first episode, whatever we did, we actually covered in the blog. More details about the whole event. It's all in the Twitch stream. So look out. We'll have more blogs. We want to make sure that we're providing with you with all the materials that's required for you guys to set up and make it as easy as possible.
Yeah, introduce as much automation as possible. So for example, what I'm doing here, I've issued a run command remotely, which means we don't need to SSH into the Raspberry Pi to control it. So it's a much more simplistic way of dealing with it in a repeatable fashion. Okay, so.
What are the components involved here, Justin? Maybe we can talk about those components.
Sure.
Yeah.
So it's many of the same components that you saw on before. Again, I'm going to use my tablet to control it. And then there's the web server running on the Raspberry Pi, which is the interface that you see here.
Yeah.
And this is how we're going to set it up to record the session. So what we're going to be doing is I'll be recording the session. The camera is now recording frames, and it's recording the telemetry, like the angle and throttle that I've done manually. So as I drive, it's going to capture the throttle and angle as I'm driving. And that is going to be recorded. That, along with the image, is then used to then train.
Cool. Yeah.
So we're going to get started. Similar to before, we start our vehicle. And now we are going to start recording. So Sunil, I probably need your help to make sure it doesn't fall off.
All right.
I'm actually going to walk with it too. There we go. It already tried to fall off. Okay. So
You went in reverse.
I'm going to try to be very careful, drive it slowly so that I can stay on the line whenever possible. For this part, speed does not really matter. We're looking more for accuracy.
Right. So the trick is you want to collect as many frames as possible. So one of the aspects is putting the throttle to minimum so that it just goes ahead, and then use that. So we'll show you a little trick as well on how you can maybe do. You want to show a little trick on holding the car?
Yeah.
Okay. We're gonna stop. And let me just quickly check. Good catch. Thanks, Smith Woodward.
Yes. When you're operating on the table, it's definitely useful to have a partner. Because you might spend too much time in the repair shop. And I can't get over that microphone at this speed, so I'm going to give it a little bit more power. And now I've got more of an off-road vehicle. But it's getting a little bit harder to control and stay on the line as I increase the speed.
All right, maybe you want to show them like how how slow the whole slow training process and holding the car.
Okay.
Actually kind of walking.
I'll control the angle, the steering. You want to move it?
Yeah.
So this is going to be a little bit more accurate. So essentially, Sunil is just going to push it, and I'm just going to steer. So we can keep ourselves right on the line.
So this is another trick of like, if you really get good training data. So the other aspect is you want to kind of like go through the images and delete moves so that you don't have a model that drives erratically, right? So another is like you can maybe have a leash and make sure it doesn't necessarily kind of go out of bound, right? The other is kind of like holding through so that we're getting, so slowly you drive, right? You're getting more frames as well. So this is a way of getting data.
And it helps you from oversteering and over-correcting, which could be a problem.
Correct. Yeah. So some amount of noise is actually helpful, I would say, when you build the model, but you do want to make sure that you get a lot of good data because that's what the model is going to learn, right? It's garbage in, garbage out kind of a deal. So do you plan on using training with the data we just collected now?
Yeah, we're going to try to train with this. We'll see what happens.
How long do you think we should train?
Let's do 2 more laps, and we'll see what we have, see how many frames we have.
Perfect. Let me look at questions.
Yeah, I'll keep going here.
So Twitchy ML says, essentially creating your own data as a fact to work with. Yeah, exactly. So, with deep learning, people might have a magical idea of trying to solve anything, but what essentially you need is data. Like it learns based on the data set that you have. So in this case, we are. It's behavioral cloning, right? So it's actually learning to drive like Justin in this case.
And we'll see if that's a compliment or not, based on how well it drives. We'll see.
So KG says, what parameters of data are you gathering in the training? So in this case, as Justin mentioned earlier, we're only using the camera as a sensor. So we're recording the throttle data, and we're recording the steering angle on a per frame basis. So that's our data, and essentially what we'll do is, when we do the prediction, it's going to sample the frames. It's going to be saying, hey, given this frame, what should be my steering angle? And that happens repeatedly, and that's how the car moves forward and makes those turns, right? Because we have a fixed throttle. Although the model does learn throttle, we'll kind of talk about throttle and other sensors in the next, episodes. But we want to start simple. We'll do the fixed throttle. We'll let the driving part, which is the steering aspect, be the highlight of this episode.
Okay. So we stopped our recording. And let's take a look at our training data.
So how many of you are training the car as we speak? Just curious.
Okay, so I've opened up an SSH session to the Raspberry Pi.
Okay.
And in the D2, which is the Donkey Car 2 that I've selected for this name, we have a data folder. And inside this data folder, there are tub folders. And each one of these has the training sessions that we've run. So let's see which one.
So can you increase the text size? Yeah. Let's make sure that people can see more. Just
more.
Yeah. Okay. That should be good. We'll wait. So Twitchy ML says, wouldn't it be different if the environment changed, different background, road conditions? Yeah, for the most part, yes. But again, it depends on what you think the model has learned, right? So if your camera angle capture, you've got enough rich data where, two distinct lines, then the model is probably going to learn that aspect. So it's hard to actually say that what the model's actually learned. So what we can do is give it samples, have hypotheses, and essentially say, hey, I'm going to chop that off, or I'm going to add objects and so on. So one way is, as we add obstacles, we can kind of hypothesize what we think the model's actually learned. Is it actually learned to, in this case, like, is it following the line, or does it say like, hey, I need to stay this side of the white line or that side of the white line. So it's all of those are possibilities what the model learns, because in this case, right, as I mentioned, it's behavioral cloning. We're essentially trying to clone a behavior, and this is just like a helper or cue in the image for the model to learn something.
Cool. So let's take a look at what we recorded.
Let us know if the text size is good. Is that readable?
Okay.
Okay, so
we recorded, let's see, we've got 9,400 files, divide that by 2. We've got about 40.
Right. Actually, divide by 2. Why do you divide by 2?
Yeah, so there for each there's an image, and then there's a corresponding JSON object.
Okay.
So we'll take a closer look at what's in the JSON.
Perfect.
So
perfect. Yeah.
let's take a look here. We'll just grab one of these at random. 983.json. This one didn't have any real useful information in it. Let's try another one. Okay.
Okay, Moss says 4x larger text. We need. Okay,
let's try.
Hopefully that's helpful. There we go.
So for this corresponding image, 834 cam image array JPEG, it was in user mode, meaning that I was driving it, human pilot, so we had no pilot selected, and I had the throttle fixed to 25%. And that was something that we showed earlier, setting that max throttle. So that was recorded along with that image, and as well as the angle. So this angle, negative 0.08, means I'm slightly turning left, just very slight. So for this image, we're doing a slight left turn.
Okay, makes sense. Yeah, and so one thing we recommend is, let's say you kind of go off track or do a mistake. It's good to kind of like, know where you've made that mistake. So going through the image and kind of filtering all those bad images out will actually help get a better model.
Okay, so this is our training data for the run.
And it's good. Like, I mean, another point, like this is a JSON file. So it's great that it's a JSON file because now it's extensible in terms of as you add more telemetry.
That's right.
And more sensors into this.
That's right. This is all the metadata associated with that image. So,
right.
Scott.
Yeah. Quick question for the audience. Like, hey, what if you were gonna add a sensor? Maybe like top choice of sensor. What would that be? I'm just curious.
I know I've got an idea. For this room, maybe we want an edge detector. Throw on the brakes if you're about to fall off or something.
KG asks, how do you recommend viewing those images on the Pi?
Yeah, that's a good question.
Yeah, so we the previous version used to have like a browser, so we'll add. So if anybody in the community wants to add that functionality, or if we get some time, we'll add that as well. We'll add a little browser where you can select and delete images.
That's where you pull
through
out the bad images. Yeah.
Correct. So yeah, we'll work on that. So Mossman says Donkey Tub data starts a web server to view tubs on port 8886. There you go. Donkey Tub data. So if you do that, it's actually built in. Babu Srinivasan says collision sensor would be cool.
That would be useful.
Thanks, Mossman, for answering the questions. We keep iterating, so we're on a slightly older build here, yeah. So we'll keep actively adding more data. We'll send a pull request back to the community. Yeah.
All right. So we've got this training data. What we're going to do now is we're going to copy this up to the Deep Learning AMI running in AWS, and we're going to create a model out of it. And again, the reason for this is the Deep Learning AMI is much more powerful. It's going to be able to go through these 4,700 images.
Yeah, for folks who are not familiar, so AWS is a deep learning AMI, which is available at no additional cost. It comes with, you're only paying for the server that you spin up. So in this case, like we don't have a lot of images, you might be okay like with a powerful CPU machine as well. But you can have a GPU machine. You have second billing, so you're only using for really what you
That's right.
use.
You don't need it running all the time. It's really when you just want to create a model.
Correct.
And like Sunil said, the per second billing, if you run it for 7 minutes and 15 seconds, that's all you're going to pay for
that. So it's amazing. But more importantly, what it does is it actually comes up with all the necessary goodies that a data scientist or a deep learner wants. So it's got SciPy, NumPy, Anaconda, if that's your way of handling with Python. But also, it's got all the popular deep learning frameworks, including TensorFlow, Keras, MXNet, Caffe. All of those are pre-installed, and the NVIDIA CUDA drivers as well. So in less than like a couple of minutes, you can get the instance up and running with pretty much all the libraries you might need.
It's the full kit, yeah.
It's the full kit. So, and it's... the good thing is it's actually maintained by AWS, sort of nightly builds, and we have a monthly cadence in terms of releasing or refreshing the AMI. So it's Ubuntu version and Amazon Linux, but as a developer, I would probably recommend using the Ubuntu version more. So yeah, I think that's a really easy way for people to get started on deep learning, and we highly recommend using that and getting your donkey build. And the good thing is once you have your setup, you can just stop the instance. You only pay for the EBS that you have backing the instance, and then you can spin it up when you want to train again. So really flexible, and that's the best practice we recommend in terms of dealing with the whole setup. And we'll make sure this is articulated in the blog.
That's right.
Help you guys. We get a little clap for per second billing.
Ooh, yeah. So let me get this next command going, because essentially what we're going to do is we're going to do an rsync command to copy this data up to the deep learning AMI. So let's get that going. And that's going. So we'll give this just a few minutes to copy up all of our images.
Right.
And then we'll switch over to the deep learning AMI and start the training process.
Okay, it's sending the incremental file list. While this is happening, you want to show the instance and maybe walk through. Yeah.
Yeah, so let's switch over. Oh, it's already done.
Oh.
Very cool. Let me make this bigger as well. See how that looks.
Okay.
Okay, so now we're on the Deep Learning AMI, and we did copy everything to this D2 data folder.
And so you have the SSH key.
That's right.
On the Raspberry Pi.
We copied the SSH key for the Deep Learning AMI to the Raspberry Pi, so it would have the credentials it needed to rsync back and forth.
Okay, makes sense. Okay,
so the tub file that we copied earlier was, let's see, 34, 17, 10, 13. Okay. Here it is. Cool.
Yeah.
All right, so now we are going to train on this. So we're going to do Python 3.5, manage.py, train, and then we're going to put in our tub.
So that's the command, right?
This is the command to train. We're pointing it to, oh, sorry, go ahead.
No, I was just talking about, so the manage.py is basically our interface into kind of handling the project. So you can train, drive, all of that is there. So that's kind of your entry. So in this case, we're running the manage.py with the train. Essentially, we're training. We can give it the tub, essentially the directory, and you can give it multiple directories as well, because more data. You might have different sessions that you had while training, and we can maybe try, like if we have time, we can try training the model with just the images we collected on the stream, and also all the images we've had.
Yep. Okay, and now we're going to name the model.
We'll call it live Twitchy model.
Live on Twitch.
All right.
TCH.
Do you guys have questions? Let us know. For folks who are just tuning in, hey, welcome. We're actually doing a Robocar Rally at reInvent, where people get to hack on a car just like this, and teach it teach it to actually drive by itself. So it's a self-driving car. We're going to have a racetrack, so once you kind of kick it up, we're going to kick it up a notch, and we'll do a race. But we're going to have a series of blog posts and Twitch streams to help you kind of get ready. Get ready for reInvent. Today we're focusing on how do you train the car. What are the best practices on that? We're gonna actually have it go live. So we're gonna live train it. We did that. Sorry if you missed that. But now we're gonna live build the model and then use that trained model and let the car run. So you're missing the dash on the tub. So
Thank you.
It's dash tub.
Thank you.
And there we have Mossman as well, recommending that you had a double that. Thanks, guys.
It's always better.
So you always have more eyes.
Yeah,
always good to have more eyes.
Yeah. This is definitely a fun team project to do as well. I mean, it's one thing to build on your own.
Correct.
But there's so many, just to get more people involved.
Absolutely. Nubin official says, "Hey bros, I guess Nubin joins us from Russia."
All right.
Yeah.
Pass doesn't exist. Looks like I'm missing something here. Let's see. Train, tub.
All right. So let's see.
What am I missing?
The path exists and you pass info.
Tub.
Let's see. I'm reading the errors as well. So data slash Is the path there? Which folder maybe?
The path to tub.
Yeah.
Oh, okay.
Yeah. So.
Tub /
And make sure maybe the model directory that you need is correct. Instead of // have it use the, I think the model directory is in the home directory, so use tilde / model. No. That's fine. Okay.
I think this is what we got to work before.
Okay.
Let's try this.
Yeah, I don't know the path on your laptop, so. Okay, let's enter. Oh.
There we are.
Okay.
We're training.
Okay, perfect.
And you can see this makes pretty quick work out of this.
Yeah.
When I was initially starting this, I was just training on the Raspberry Pi, and you would spend a good 20 or 30 minutes just waiting for this training to happen, and it wasn't really an effective use of time. When you want to keep iterating and driving and training and driving and training,
right.
When you introduce a 30-minute
right, I mean, and that was a small data set, right?
And it was a small data set.
As you see the hackathon, if you want the car to really perform, we're going to have a lot of images, and as you add more complexity, it's not quite. I wouldn't call it advice training on a Raspberry Pi. Highly recommend syncing it, using a training environment on AWS, which will help you train really fast.
That's right.
And
in our case, we're using a G2 2X large, so it has an NVIDIA card in it. So we're training with a GPU, which is much more effective than CPU training.
Yeah. So we got Twitchy MLs asking, is manage.py from a framework? No, I mean, that's actually part of the Donkey build. So manage.py by default uses a Keras, so it's got a Keras model, and that's what is inbuilt now. And as I was alluding to earlier, we're going to be adding a lot more support, so you'll be able to choose other frameworks like MXNet, maybe directly TensorFlow, and PyTorch. So you get to pick what framework you use. It's beneficial when you have a lot of data. Some might train faster, so you get that benefit. And in this case, Keras essentially uses frameworks like Theano, TensorFlow, MXNet, even CNTK as the backend. So you've got the possibility to change backends, but keep your front end code the same.
So there's a lot of information that's output here. Sunil, do you want to talk about what we're seeing here with the different epochs and the loss scores and what early stopping means? Because this is pretty significant to the deep learning process.
So, an epoch is when the training process of the model has actually seen all the data samples. So we had about 5,000 data samples. So in epoch, we have 5,000 data samples that was seen by the model. And that's and what happens is you want to actually train, like give the same data multiple times. So as the model actually sees this multiple times, it gets better at identifying and learning.
So it itself is iterating on it.
Yeah. So epochs are essentially iterations. So early stopping is, so what we do is we divide the data set into a training set and a validation set. A training set is where the model actually gets trained on. A validation set is never seen by the model. So it's only used for the prediction.
So a portion of those images that we took is only for prediction.
Correct.
Yeah, okay.
Essentially what we're trying to do is a validation set prevents or actually helps us know how the model does on the data that it's never seen.
Okay.
Right? So there's a concept called overfitting, and what model does is you're showing it the same data, it just really gets really good at doing things for only that data. So it's really becomes very it overfits, right? So it understands that data too well.
So it's very specific in what it knows.
Correct. And what we want is a model that is generalized, right?
Okay.
So maybe like, we put the tape on the floor and it gets working. Or we, slightly augment the course and it works. So it's really important for us to have a generalized model.
Right, because especially with driving, you want that flexibility.
Correct.
There's a lot of unpredictability
Correct.
about what might be
Correct.
in the road, where the turn
Right,
goes.
and it's going to be fun once we add obstacles and see what happens. Is the model that we learned like really generalized? And so that's where the validation score happens. So when we actually, so if you think about this, we, curves in terms of how things improve, we want a point where the validation accuracy is the highest.
Okay.
Because that's when we know the model's been doing good on that data set that we kept aside. What we don't want is when the training accuracy says 100% and the validation accuracy is 50%. That means you're not doing too good, right? So validation accuracy is where we want to look at. And early stopping is when, when we're actually going through the iterations and we're only getting diminishing returns.
So we're no longer improving.
Correct.
It's
improving. So Keras is this good functionality where you can stop and you get the model.
And is the loss the main indicator that we're looking at, or is there other values here?
So the loss is essentially showing us it's the metric. So loss function is telling us how far off are we from the actual like desired outcome. So the loss function, we are minimizing the loss function. So you want to see the loss function reduce. As you can see, like on the screen, it's at like 0.7, and it goes all the way down.
In our first epoch,
yeah.
Where were we?
2.7.
Yeah.
So we start at 2.7, it goes all the way down, and hits at 0.47.
0.47, yeah.
So that's pretty decent progress in terms of where we got.
Now, does that mean I did a good driving, or the model did a good job predicting what I did?
That's a good question. In this case, the model did.
Okay.
The model did. How well of a driving you did, maybe we'll
see in a few
we'll
seconds.
see in a few seconds. Yeah.
Okay.
That's maybe you want to copy the model over.
Sure. So let's copy the model back. We're going to go back to the Raspberry Pi. We're going to do a similar rsync, but this time just to get the model back.
All right. Okay. Let us know if you have questions on the whole concept of overfitting, epochs. Happy to explain. So Justin's rsynching from the model that we created onto the Pi. So okay. KG asked, what are the things you can do to prevent overfitting? I'm not going to go too much into details, but there are concepts called as dropouts. You can have a lot more training data, augmentation. So dropout is a concept where we will turn off a few of the nodes in the network using just probabilistically. That way we're reducing the number of parameters that are improving on the parameters essentially in the network. So essentially keeping the network a little more generalized.
Right. Okay, I've copied the model back.
Okay, perfect.
Model is good to go.
So this is you rsynced essentially all the models.
Just the models back, yeah.
It's got all the models, previous ones and new ones as well. Great.
But there was only one new one that's live on Twitch.
All right.
That's all we had to copy. So now what we're going to do is we're going to start the car using this new model. So Python manage.py drive model.
Arctic S says, hi, just joined. What ML algo library are you using? How are you training it? Hey, for the car, we are actually doing a convolutional neural network. So that's the network we're using. We're using a 5-layer CNN, I believe. I forget the iterations we've done. We can show the code. And the library we're using is Keras with the TensorFlow backend to train. As far as training, it's actually inbuilt. So we've collected about 5,000 images with telemetry data. In particular, we have the angle, the steering angle, and the throttle, which we've used to actually build a model. So, okay. Hopefully that helps.
Yep.
So you've
it's
got
starting up. We'll give it 1 second.
All right. And once we see the camera feed, we'll know the car is good to go. There we go.
There it is.
So,
okay, so essentially what we're going to do here is, again, I'm going to set the max throttle, because even though it's going to be driving on its own, we don't want it going too fast. And we're going to change it to local angle. So now, let's see.
And how did you select the model?
The model, it was was part of how I invoked it. So Python manage.py, drive, and I selected my model.
And you select the model file.
Right.
Okay.
That's
great.
right.
Great.
So now we've launched with our model. So let's see,
So now,
before we get driving.
You wanna? Yeah.
Before we get driving, let's try one thing. Let's see. Excuse me.
Yeah.
When I rotate this, the wheels should turn because this model's live. So it's seeing the line and it's attempting turns based on the line. So I've got a pretty good feeling, and I can hear it.
Okay.
That
so essentially
it's aware of the line, and the servos are.
Did I think I?
Don't worry about that. That's that's for next week, but that goes there.
I was worried I accidentally pulled a.
No.
Okay.
All right. So who has confidence that this is going to work? Everybody, thumbs up.
I'm waiting for thumbs up.
Ball of flames or great success. All right. Let's give this a shot. All right. Here we go.
It's a good start. All right. Can it curve? It does. It's going.
Whoa. Okay. All right.
I mean,
okay, let's try it this way.
I mean, it almost finished 3/4 of its course. So let's.
Maybe we'll go a little slower.
Yeah. Okay. Maybe that was.
I tend to drive a little quickly with it.
That is actually pretty damn good. It's, staying in the center of the line, and that is great. I mean, and this was just like less than 5 minutes of training. That's pretty fantastic. That's well done. I think you drove well, which the car learned. So.
And for those
awesome.
of you at home, what you'll find and what I found is using a tablet to steer gave me far better control over my phone, or just using the web interface, either with the I command or the keyboard controls. This way you've got a little bit of feel to it, just like when you're driving a real car, you've got the feeling of steering and throttle. So that helped as well.
I'm going to kick it up a notch now and see how well your driving is. So we're going to add some obstacles. We're going to mask the tape. So I don't know, maybe.
Let's put the orange juice in there. See what happens. I mean,
all right, let's. I don't know. I'm just gonna put it on the track and
see what happens.
We'll see what happens.
All right.
We got Baba Srinivasan says, were you able to integrate PS3 or Xbox controller with Donkey Car yet?
Yeah.
I haven't, but
I believe the community has support for adding other controllers.
Yeah, exactly. So I've seen people joy with joysticks. more friendly.
Yeah.
But you can do it with your phone. It's pretty works pretty good.
Yeah.
Tablet's good so that you've got more of a surface area. But yeah, driving can be a little tricky for sure.
All right, let's see what we can do.
All right, let's go. Wow, it just woo! That was pretty fantastic. It avoided the orange juice. Let me. Okay, I'm gonna put it right on the track now. Let's see if that still wasn't too bad. It tried to avoid it. It did try to avoid the orange juice.
So maybe somebody wants to build functionality for orange juice, not orange juice, and when you see the orange juice, you make a turn and go around it.
Or make a stop and drink it.
Make a stop and drink it. A little bit more power. There we go.
In this case. We did knock a few things now. That's
interesting.
That's not the way to drive, guys. not the right way to drive. But
it also shows that maybe there's some off-road capabilities of this device, that it's able to do more than just flat surfaces.
Right.
That's pretty cool.
Awesome. Let's look at a little bit of comments. Smith Woodward says, seafood, hot dog or not hot dog. CHR Wong says, hey, that's awesome, thank you. Twitchy ML says, just push all the obstacles.
You could put a plow on front. That's one way to deal with it. Just plow it out of the way.
Yeah, maybe a snowplow, right?
Yeah,
like self-driving snowplow, like. That'd be cool, especially we're streaming from San Francisco, which is not quite a worry here, but
I live in New York. Snow is a challenge. We could incorporate this with a snowblower. That would be useful.
But it's actually on a more serious note. It's actually difficult to train self-driving cars in snow environment. Because the background is just white, we don't get enough cues in the images. That's why you see
the lane, the road markers.
Especially when the snow, because you can get confused as to what it is. Which is actually why you see most self-driving cars in the Arizona, Las Vegas, or California, where there's snow in California, but a lot of places where there's no snow. So snow is actually an issue, but hopefully, you guys have ideas there. Maybe you build something that can tackle snow. That'd be great. Like have a sensor, and add that. I think we should, mute the car.
If you unplug the battery, it'll go quiet.
So I have Master565 says, hey, I'm late. What sensor data was the car gathering? To recap, we were actually doing we're capturing the angle, the steering angle of the car. Also, we were capturing the throttle. But in this case, mostly we were only using the steering angle data to learn and clone the behavior. So Twitchy ML says, does it make sense to dynamically switch the model then? I'm not sure what dynamically you mean, but the real world applications, what people do is called a model ensemble. So they train a bunch of models with different kind of data, and they average out, they combine the outputs from those models and do a giant prediction. So that's one way. People have different levels of models, and then you kind of have multiple decision makers to kind of override details. Models for different. So Twitchy ML says model for different conditions, or something that's generic. There are approaches. There are different approaches that people try. Model ensemble is the most common one, but you might think that when you're driving, say cross country, say you have a state-wise model or road-wise model, and
or a model designed for a specific road.
Correct.
Right?
Yeah, absolutely. So another, let me check. I think that was all the questions that are on Twitch. So maybe a recap, and I know you want to talk a little bit about the systems manager. Maybe we can spend like a couple of minutes there, and yeah.
So a lot of what you saw us do with starting the model here, I'm actually going to cancel it, and I'll show you a way that we can automate this with EC2 Systems Manager. So essentially with EC2 Systems Manager, we can make a document that describes a command that we want to run. And then we just execute a command, and that runs that document for us. So we're able to create multiple documents, say one per model, and then you just run the document that you want based on that model, all without having to SSH into the Pi. So let's switch back to our AWS console, and we'll create a new document.
So you go to EC2, pick
Yeah, so we're in EC2, and we are in the Systems Manager resources, and we have documents. And I've created a number of them, and we'll create a new one now. So we're going to call this Live on Twitch. And essentially what it is, it's a command document. Make this a little bit bigger. And I'm pasting in my JSON here. So essentially, this is the command that we're going to run down here. Manage that PY and drive. In order for it to do the model that we selected, we have to copy that command.
So essentially, like, yeah.
And we're going to say...
So it simplifies essentially, like, I don't need to remember all the things.
No.
It's just parameterized.
No, and the nice part about these documents, you can create multiple revisions. So if you want to change certain things, you just have different revisions of the document. You change...
So it's a more controlled way of managing your
That's right.
systems. You don't, like, well, what did I do? And like look at bash history, like, which is what I keep doing and trying to remember. Well, I think it was on October 22nd.
And what's really nice about EC2 Systems Manager now supporting Raspbian, we're able to essentially entitle the EC2 SSM agent that we've installed to execute commands on AWS.
Okay.
So we've given the permission to run these commands and to do these things.
Wonderful, wonderful.
The other nice thing, if you're taking your car with you on the road, you may not know what the IP address is.
Correct,
right?
yeah.
And in this case, I'm tethering it on my phone. What's my external IP?
That is true, guys.
I don't know, but I don't need to.
Yeah, we'll make sure we add a little more documentation on or just helping you guys know the IP stuff. But Systems Manager makes it super simple because I've had the problem myself, like going through LAN scans and trying to find, well, that's my Raspberry Pi.
That's right. That's right. So we've simplified that. And I'll show you that in a moment. So this is the command that we're going to run, and it's described as a document.
And just FYI, we're going to have a blog post that's going to release early next week, and we're going to have a more walkthrough with screenshots. So stay tuned for that blog.
It'll be a full step-by-step to build the EC2 Systems Manager functionality. But essentially what we've done is we've created an activation. And when you create an activation, you get a unique code. And it's this code and ID that you then put on the Raspberry Pi, and that authenticates it. So once we do that, it goes from being an activation to a managed instance.
Okay.
And so now we've got all this other metadata about this instance, right? And so it's describing what's on the Raspberry Pi. We can do other things built into EC2 SSM. We can do inventory scans or do automated patch and deployments. There's really a lot of features and functionalities in SSM that you could apply here. So this is an interesting place for people to continue to add creativity to it.
While just 1 second, just curious if people want to have ideas on, before we end the stream, on doing something cool with the car, or maybe doing one more lap, let us know. Think about it. Let us know while Justin's talking about the SSM.
Yeah. Okay, so I'm going to go to the run command portion, and I'm going to run a command, and I'm essentially selecting the document that we built, and I'm selecting the instance that we want it to run on. So in this case, I only have one car. This is the instance, and we are going to run. Success. So now let's take a look at this. We'll give this a few moments, and when it's ready, the web server should be invoked, and we should have an image on the screen. So let's give this a few moments to get started. And failed.
Is that because we have multiple on the same pie? Or
No, I may have blown the path here a little bit. No such manage.py. Let's take a look.
Yeah. Yeah, I think you need to
Let's take a look.
give it the entire path and not ~d/d2.
Yeah,
Because,
let's try this.
yeah.
Okay, so live on Twitch. So when you make a mistake, you just create a new version.
That's easy.
And we're going to call this one.
Well, we've all had that problem with relative relative pathing and absolute path. So always good to use absolute paths.
So we've created a new document. In order for this to work, we want to set it as the default. Document 2 is now our default. And let's try to run this again.
Are you sure we got the paths correct?
I believe so.
Okay.
No way to be sure until I run it, though.
I'm still waiting, guys, for ideas on, just before we end the stream, some ideas on what obstacles maybe we can add, something crazy with the car. Please let us know.
Let's see. Oh. A minute. There we go. So we've executed that command. We don't need to SSH into this car again. And just let's verify that it runs one more time. Oh, I think I unplugged the battery. Can you plug in?
Yeah.
More throttle.
And it was driving by itself. Is that true?
Yeah, let's see.
Hope your driving is not that bad.
Me too.
Oh, yeah.
Let's try it again. Here we go. Oh.
That was a little too fast.
A little too fast. Let's slow it down. I think the battery on the car is starting to wear down because I have to, there's like a threshold where if you don't give it enough throttle, it won't even move once it wears down a little bit.
You got some compliments on your stuff by Smith Woodward. It says the car likes the cable up there.
Yeah, it seems to be going right for the cable.
I think, that's actually a good indicator, right? I think what model has learned, I think people talked about what it may have learned. I think it's trying to stay between the model here. The line here. So the cable actually looks like a line, and it does think, it wants to stay right in the center of that cable.
But there's another thing that's going on here. When you train, the best way to do it is really to stay out of the frame of the camera, right? Because if I'm in the camera and it sees me, it may want to just drive towards me because that's where I was last time. So the recommendation is try to keep, while you're training, as static as possible and walk behind it so you're not captured in the image because there's a lot of other distractions.
Yeah, no, totally makes sense.
Unless you want it to drive to you, then that's what you'd want.
Right. Cool. Yeah, thanks, Justin. I think this has been super cool. Like we've been able to build a car in the last episode. This episode, we actually showed you how you can train the car, and we actually did this live. You saw how easy it was. Less than 5 minutes of training. The whole model setup, we got it up and running in another 2 minutes.
Yeah.
So it's fairly easy for you guys to get started. A lot of the heavy lifting is being done either by the Donkey framework or in terms of the training and the setup on AWS. So really easy for each one of you to actually get started. So please send us ideas. Tweet at us #Road to Reinvent. Let's give us ideas on what we can present. Hopefully we can see you at the hackathon. Send us pictures of the cars you build. So let us our ideas and other extensions we can build into the car. So we'll have the stream next week on Friday, live from New York, 10:20. So thanks for tuning in. And thanks to you for everybody in the community to actually help out debugging and helping answer questions.
Yeah, thank you.
Thanks a lot, guys. We'll see you next week. All right,
Take care.
cheers.
Thank you.